Hello everyone, today I'm going to present my MHF4U Unit-6 mixed unit assignment. So let's get started. And first of all, we have this question here. This basically asks the delta B. This is the change of bacteria. So the thing is that you just have to subtract the value, the successive and the previous, of course, and we get the value. And for delta T, the interval is O2. And to get in the average ROC, you just have to divide delta B to delta T and you get the value here. So, and here we have this average rate of change over 10 hours. So we subtract here from this value to this value by 10 and we get 255 bacterium per hour. So moving on to number 2, we get here is that average ROC, of course. So we first have to find the value of height at 0.8 meter, which by substituting value we get 4.764 meter, and at 1.8 seconds we get the value of 0.204 meter, and the average rate of change, of course, have to be found in this way by just subtracting these two values and dividing it. I'll get the derivatives here in minus 4.74 meter per second. And number B is like because of the due to the gravity slowing the speed of the ball over time, you could say the object traveled the fastest just after the short, which means like the uppermost point of the object reach. So as the height progresses, the speed just kind of decreases due to the gravity pulling the ball downwards. So we can infer the steepest part of the curve is around t is equal to 0. So the velocity would be, of course, naturally be the fastest as t is equal to 0. And to get this vertex or the uppermost point, we have to found it here with the equation here, minus b by 2a. So this is a, this is b, and this is c. So we get the value here. In order to, and then we get this value. From this obtained value, we found this two upper bound and lower margin, upper margin and lower margin, two values, which is going to be used here into finding the derivatives. In the cases of instantaneous ROC, we have to always do this. Put this value and take this, estimate those two values, and then find the derivatives. And D is that, of course, average ROC is, of course, different to the instantaneous ROC, because instantaneous ROC is really about, taking the estimated 1 point and finding the lower and upper margin and finding the just estimated portion of derivatives. So, which show, of course, is nearly to 0, which show the projectile motion stops increasing and peaked. Yeah, and number E, because it's at the peak of the parabola where velocity is equal to 0. This is here. The instantaneous rate would be near 0. Moving on to number 3, we get here by just found the value here, and we get it here. And number B is that the warmest day would be the thickness of the ice would be minimum. Thickness of the ice would become minimum. So this would be around day 3 and day 4. Of course, from judging the graph, we get it here. And number C, we found this estimated value and found lower and upper margin as usual. We get negative. This is because about the instantaneous speed, the value itself is selected near the point, not by calculating the exact derivative as I have told it. And number E shows like the difference, because average ROC is, of course, generally in decline, but instantaneous show little variation, which means rise and fall at a specific time period. Moving on to number 4, I let the equation into V into T. I find these two values and found the average ROC by substituting here. And number B, we get here, we found this average ROC2 as well. We found these upper and lower margins, and we get the instantaneous ROC. of around 700 minus 700 liter per minute. And at exactly 10 minutes, the volume of water is this figure. Moving on to number 5, we get here T is equal to 0 would be P is equal to 0, which means like this is the beginning of the period or the year. So by having these two values, we can find the average ROC, and we get a 555 people per year. And we get this upper and lower bound here. And as usual, we found the instantaneous ROC. And the difference between answer B and answer D is the B is the total growth because we found the average ROC. But in D, as usual, as I've told it, just one is like the the population progresses over 10 years, but in D is the instantaneous ROC. So just finding the estimated derivatives at specific points. So moving on to number 6, we here get what does average rate of change represent? So the rate of change of stopping distance here, as you can copy it here, stopping distance here per kilometers per hour as the unit show. And as usual, I found it here, an average ROC respectively, here, here, and here. And number 3, the relation is directly proportional, so one increase, another increase. So number D, so we can substitute this value and we get the value. And number E, we center around this value, found the lower and upper margin, and get the instantaneous ROC as a result. So that's all of my presentation, and thank you so much for your attention, and I hope you really enjoy it, and thank you.